everyone. And I hope you are feeling better because it's the second half of the session. Okay, so for our next session, we are excited to welcome Hammer from Ververica. Hammer will introduce the topic about from hours to seconds, how Peru's largest bank achieved 90% savings through mainframe offloading with real-time data. So welcome, Hammer.
Thank you very much, Jark. Hello, everybody. As you might notice, there's a different person on the slides, but we decided to leave him there because as my colleague Johnson, he's currently stuck in an airport because of the situation in the Middle East and airspace closing, but he's doing his best to make it all the way here. But I need to present his slides. Luckily, this is a project in which we have both worked. We know the customer very well, so hopefully I can give you an almost as good experience as Johnson would do. My name is Jaime. I work as the head of marketing at Ververica. I have a background in engineering as well, and we are here to discuss one of our recent successes, which we think is a really interesting model for large users of data, especially those that use mainframes. And we decided to start with a quick history lesson about mainframes. Does anybody of you still rely on mainframes? Or do your companies run mainframes? Lucky you, good. But you probably have heard about them, the good, the bad, the ugly, the complex, the expensive. Nobody's ever excited when they receive their bill for MIPS for a mainframe or when they have to do an upgrade. But mainframes are the logical evolution from like the most primitive computer with punch paper cards, things that Charles Babbage theorized in the 1800s, Ada Lovelace developed in algorithm theory in the early 20th century, and still kind of run the world in many ways. What we see behind a lot of the banking transactions, probably the computers that are opening and closing airspaces and rerouting flights and keeping Johnson from being here are also mainframes. But they became mainstream in around the 50s, 60s. IBM made an amazing success story out of them, so did other providers. And overall, they're just kind of powerful computers, physically owned normally by the end customer that run batch programs. Basically the same thing that kind of punch cards did in the early computing is still done by mainframes now. Don't expect to see extremely complex logic or extremely low latencies. They're good for crunching large amounts of data reliably. And something that actually still connects mainframes to my colleague Johnson, when he started working, he actually started working on mainframes, on private mainframes, and debugging the transition of his first employer from a mainframe to a more modern setup. So he very much feels the pain, and it's a pain that we can empathize through and with our customers because we both know how annoying it is, but how dependable it is. We have another colleague who always says that mainframes are too good to be replaced safely or too profitable to be replaced. And that's why they're still the backbone of a lot of what we do, a lot of the applications we use and love, your bank, your insurance, your airplane, your financial transactions. They still do really interesting things. And that's why we haven't gotten rid of all of them, even though most of us are trying. They're really good for scheduling things, for things that you know reliably when they're going to run, and to massively parallelize these programs. All of the top 10 insurers in the world run still mostly on mainframes. And conservative estimates said that about 70% of the world's data is still executed or computed by mainframes, as are about 90% of the world's credit card transactions. But contrary to what many people think, nowadays you can actually modernize these things that are too profitable to touch without ripping and replacing. And that's exactly what we are here to do. What we're here to do is, quite literally, reduce operational costs heavily for our customers by moving away from those mainframes, which you'll hear plenty in the presentation, a term called mainframe offloading. It's probably the sexiest term next to AI for banking executives and banking CIOs and CTOs. And luckily, at the same time that you drop costs, you can actually accelerate your processing, drop latency by a lot, because let's be honest, these were machines built in the 70s, 80s, early 90s. Now we have much better, more powerful technology. And you can also get your company ready to run like in an AI kind of mode of operations. You can start running AI applications that are not possible with high latency and relatively antiquated capacity of mainframes, but are possible with cloud or streaming technology. And the story today is how one of Latin America's biggest banks, based in Peru, achieved exactly this. And what they achieved was a drop in execution time of over 40%. They reduced their bill to their mainframe provider by about 90%. And they were ready from pilot to production in 3 weeks. Their calculation is with the one process that they're operating now, they're saving about 1 million Peruvian soles per year. Those savings mean that they can invest in providing better customer service, that they can run more profitably, and they can overall expand the reach of their bank to, let's say, unbanked communities that are still prevalent in Latin America. So they can become a bigger, better, more profitable bank, and this is one of the critical enablers. They are, as I said, the largest bank in Peru. I shall not mention them by name today, but they have a market share of almost 1/3 in both deposits and loans. They experimented a massive growth during the pandemic because they are able, as the most innovative bank in their country, they're able to provide banking solutions for unbanked people or people without access to a physical bank office. So things like digital wallets, peer-to-peer payments are things that exist in the bank in Peru and don't exist, let's say, in neighboring countries, don't exist in other comparable populations. But they were able to deploy that very quickly during the pandemic. And they manage about 39 billion in total assets, which for the size of the country is a very significant chunk. And as they told us, they got here by being bold, by being innovative, and by being ahead of the competitors. They want to keep that edge. They want to grow that edge. And they are going to grow that edge by minimizing batch processing and moving whatever they can to real-time data processing. Their CIO told us, literally, I want to kill batch by the end of this year. That requires that they change their tech stack. And a part of that tech stack are those 1976 mainframes. And overall, they want to minimize their dependency on mainframe for other reasons that I will explain later. But basically, you can imagine that the best and brightest talent that's coming out of a technical education doesn't know and doesn't care much about mainframes anymore. So they want to maintain that edge. Their challenge number one, their processes are by nature batch processes and they're risky. For example, their overnight main processes like interest calculations for overnight interest rates, for account statements that every customer of the bank sees in their banking app or can see on the internet, for account balances and moving, let's say, money that has been kind of committed throughout the day, moving to the actual account where it has to be overnight, and for fraud detection. All these things they have been doing in batch. And they have a one single 8-hour job, batch job, that has 30 days to change what you would call jobs. It's very brittle, it's very fragile. If one of those jobs fails, if whatever, the machine, the disk, the memory fails, all the 30 fail. And the bank has to run for 1 day without proper account statements, account balances, and they're basically kind of operating on 1 day old data, which for a bank of that size is actually quite bad. That means that they don't know if they're complying with regulations. That means that they have to be extra careful when issuing new loans. That means that they don't know if they have enough liquidity or if they have overexposure to certain markets. So they want to get rid of this risk as much as they can. And all of this application logic is written in COBOL. Again, another thing that still runs the world, but it's a product of the 70s. Just like I said that not a lot of the best talent cares or knows about mainframes, not a lot of the best talent cares or knows much about COBOL. The average age of COBOL programmers in the US is about 62 today, They're pretty close to retirement. I assume that in Peru is pretty similar. And they want to reduce all this risk that their batch is bringing, as I said, like less loans that they're able to give because they're not sure whether they're complying fully with all the regulation. They don't know about their solvency ratios, and they're afraid of regulatory penalties if they have, say, insufficient capital of the right type to meet the regulations. Challenge number 2, setting money on fire. The cost of their mainframe operations is very large, and it used to be the big cost of the bank's IT infrastructure, which they want to lower and redeploy to more productive things. Mainframes are built based on a unit that's called MIPS, which is millions of instructions per second. And they have to, let's say, buy these on credit from the provider of the mainframes to be able to run their processes. But they can't really forecast this. Or for them, it's very difficult to forecast it accurately. So they have to overbuy and then adjust. And overall, they're spending millions of dollars a month in those MIPS without a ton to show for. They also see this as a break to their growth, because basically the more transactions their clients make, the more value they provide, the more MIPS they spend. And they want to break that coupling. They want to be set free to innovate and to deliver more value to their customers. Challenge number 3, what my colleague Johnson says, that COBOL programmers are hen's teeth, impossible to find. And more so in their market. So at their bank, there aren't many left. Universities aren't training new ones. And nobody really is very interested in a promising career jump to deal with 70s infrastructure. So they have identified this dependency on mainframe and on COBOL as one of their critical kind of risks. So if they want to stay ahead and be able to use their best people and the best in breed technology, they want to get rid of COBOL and mainframe. And their main restriction here is that they can't afford any downtime. Can you imagine, like, would you be very happy if your bank stops working for a day or a week? Probably not. If you need to pay your mortgage, your rent, if you suddenly happen to be buying a car that day or a present for your kid, you're not going to be happy. And when the risk is not one unhappy customer, but 52 million unhappy customers, it's probably much worse. So with all this impetus to move forward, they have to be extremely careful. So for those reasons, and because they want to look to the future, a new mainframe, as shiny as it could be, is not an option. They want to get out of that, and they're getting out of that. So they're looking for a solution that guarantees their 3 key pillars, which is resilience, the bank has to be up and running, robustness has to be relatively difficult to destroy or disrupt, and performance. They want to get away from that 8-hour fragile process into something that they can rely on better. So we started working with them in a proof of value approach. They did evaluate some vendors. We were happy to be the chosen one. And what we did to prove this value with them is to pure and simply benchmark them. They defined what was value for them, and they had their highest consumption job. It's about 4 million events per second of one of the 30 parts of that daisy chain. We worked with them, we converted their COBOL to Java. We set up kind of a Java application with Flink SQL that ingests their virtualized file and runs a process. And basically, when they run our unified streaming data platform, they're able to go down from those 2 hours estimated runtime of that one job from 2 hours to about 8 seconds. And when you expand this to cover the 30 jobs, we are expecting a reduction to, let's say, from 8 hours to an order of a minute or 2. This is actually how their high-level architecture looks like. So they're reading virtualized files that their mainframes have been providing, at least for this one job. We ingest them. Right now, they're using a different solution for storage, but we are already plotting how they're going to move to Apache Pymon, which you heard about this morning, as a kind of a durable and hardened storage option for streaming. And they have different kind of processor nodes here, which will in the end, output a report, be it account status, be it solvency ratios, be it cash position. And this slide looks extremely complex. It was done on purpose. And also on purpose was left the title, Seamless Integration. This looks very difficult, but it isn't. So the vast majority of this is how they run now with their mainframe. Their VSAM files outputted by the IBM mainframe run like an application module with about 30 jobs, of which we decided to replace the most complex one. And we call the job add, which calls like a Java function that then basically executes their workload on our platform. On different Flink modules, we will kind of provide them also like a green-blue staging deployment where they can develop safely on top, and eventually we'll get rid of these 30 jobs into kind of a much more hardened solution that will go from those 8 hours to about a couple of minutes. So eventually at some point, this will be history, and this will be running the show. And the question that you might be asking yourselves that they asked us is like, why should they go with us? And after proving that value, after that proof of concept, taking care of their most difficult, most critical piece of the daisy chain, what we were able to show them is like, this is stable. This is as solid, if not more solid, than what you're running today on mainframe. They're going to have absolute certainty of process, plus a lot of margin to spare, because they no longer take 8 hours to run the daisy chain. If anything would fail, apart from the fact that there are multiple checkpoints, that there are multiple redundancies, which they couldn't afford before because they didn't have time, we are achieving success rates higher than those of the mainframe. Also something they cannot get with a mainframe, but they can get with Flink, exactly once processing. This sounds irrelevant or nice to have until you do things like verifying transactions from one person to another. And you need to make sure that, okay, did this transaction actually reach both parties? And if not, replay it. You cannot really afford having a transaction duplicated or never processed. So that's something that Flink gives them that they didn't have before. Their security of, or let's say the degree of certainty of them knowing that transactions are going to be exactly verified is much bigger now. And overall, it's much more reliable. It's much more hardened. This is an architecture built for the 2020s, not for the 1970s. And for the amount of transactions of the 2020s and not of the 1970s. And what they were particularly happy with, which they didn't expect to get with this, but they appreciate, is that their developers can actually focus on those jobs, can actually focus on the architecture, and not have to deal with all the overhead. How am I going to virtualize my files? How am I going to build failsafes? How am I going to build a scheduler for these mainframes? That's gone. They don't have to worry about it. It's basically table stakes in Flink. What's important for them? Their business impact. Their execution time reduction at a minimum is going to come down at a 40% for the most complex processes. And their spend in MIPS that they're paying to the mainframe provider, already now they're seeing a 90% reduction, which means that now they have millions of soles or millions of dollars a month to build out their capacity to provide various services, hopefully to build more use cases with us. What they expected that would take a quarter, it actually took 3 weeks, which means that we are already working and we have confirmation that we have actually just deployed another use case with them last week. And overall, with this one single process, they're already saving about $1 million per year. And this is one very concrete example of how a bank can actually leapfrog into the 2020s and do what they need to do in a modern, robust, cost-efficient way. This is, for example, how other of our customers, banking customers, do fraud detection. We just had an excellent talk half an hour ago in the neighboring room about how an e-commerce platform does fraud detection. But we have banks that do fraud detection as well and can use a very similar architecture to, within milliseconds, be able to approve, decline, or ask for extra verification for a transaction. That transaction can be a payment request with a credit card, can be a peer-to-peer transfer, and we have over a dozen of customers that have these sort of use cases ready and in production. And that, if that refers to what's live today, this slide refers to what's going to be live tomorrow. So we heard this morning a whole lot about how AI is changing the game, and it's a new normal. We're ready for this too. And we have invested engineering effort in making sure that our platform supports going from this world to this world where these different banking core functions are going to be performed by different agents that are going to do know your customer completeness evaluation, that are going to do anti-money laundering compliance, that can do reporting on an agentic way. And overall, we can get this sort of banking architecture for maybe the 2030s on and onwards. Then fraud is going to be a whole different game where we don't have to wait days or weeks to detect it and to stop it, but within milliseconds, we can actually get in front of it. So our value offer as Ververica, the original creators of Apache Flink, is that we can offer resilience for both streaming and batch. And we can offer kind of one platform that will take care of your needs for both streaming and batch, and a platform that's 100% compatible with open source Apache Flink. And to those who own a mainframe, we can allow you to schedule your jobs and have that granular, durable scheduling control better than you would have on a mainframe, all kind of in one single data platform. This customer in particular is already using those savings and investing into becoming or staying the preferred bank of Peruvians. And they're doing these sort of things that we just discussed with agentic AI for fraud detection in real time. And they're also using some of this engineering time to remove the data rewrite back to mainframes so that they can, at some point, once and for all, get rid of the mainframe as their backbone and use a more modern system for storage and processing of their core data. We have a demo that we tested just before. Unfortunately, it didn't work on the presentation, so I can offer you a QR code that you can scan and you'll be able to see it live. It's a video where you can see how transactions are coming in real time and how our Flink job is proactively flagging them as potentially fraudulent, high risk, low risk, approved, etc., etc. And that will be the end of my time. I invite you to either join us at the booth downstairs or scan the QR code to check us out on our website. It's been a pleasure to be here with you today. Thank you very much. I'll be happy to take your questions. Question?
I think most of the use case that you showed just now is offloading batch processes on
Yes.
the mainframes, right? Are there any real-time that?
On their mainframe, no, because the lag that they have on their mainframe process is too big to do basically anything in real time. Things that they want to do or already do real time don't go through their mainframes, such as peer-to-peer transactions. Or they have also an app, and kind of that app basically doesn't read or write to the mainframe, but relies on other systems to feed the app. And I can kind of dig deeper into this later if you want to explain you how they're doing it. But my statement here would be that if you have to build something now, build it for the real time. It's the way to go.